Hello there, you beautiful people, and welcome to this section on numbers. Now, this is a really important section of the course because in here we're going to learn the inner workings of so many things in computing. Things like computer vision, web pages, and even Google Maps all use numbers to get stuff done. Now, this lecture is just an overview of the coming section, and it should serve as a briefing for what is about to come. But by the end of the lecture, you should know what we're doing next and be super excited to jump right in and start using numbers in Python. We're going to start off, as always, with the basics. The first lecture will cover how to do basic arithmetic in Python. That is addition, subtraction, multiplication, and division. And once you've learned all these, it's quite possible that you'll never need to do maths in your head ever again. And once we've got the basic arithmetic down, we're going to start doing more complicated processes and learn about how we can control the way that the computer will work the answer out. This is very useful and is going to give us a lot of confidence when doing rather complicated things later on. After that, I'm going to introduce you to a new data type called the float. And yes, floats are as cool as they sound. Then we're going to jump in and create our first project. We're going to tie together what we've learned about variables in the last section, along with what we're going to learn about numbers in this section, in order to make a health potion for a video game character. Our project will be able to deal with different game difficulty levels and will really give you a good demonstration of how numbers are used to make things work in computer programs. This project will also introduce us to the Python random module, which we will use to make a random number generator. By doing this, we will learn how to use Python libraries, and this means we can leverage work done by other people to make our code even more awesome. After that, for those of you who are interested, we're going to cover other mathematical topics such as rounding, powers, square roots, some basic trigonometry, and go into more advanced topics using the Python math module. This will be particularly interesting to those of you who have come from scientific or mathematical backgrounds and want to see what Python truly has to offer. Finally, we'll have a section review, and then there's going to be plenty of coding challenges for you to have a go at to check that you fully understand the concepts covered in this section. So hopefully you have a good idea of where we're going to be going in this section, and if you're anything like me, I bet you can't wait to get started. Let's get right into using numbers in Python. Hello there, you beautiful people, and welcome to the first lecture in the numbers section of the Python Bible. Now, of course, no numbers section worth anything would be complete if it didn't tell you how to add, subtract, multiply, and divide, now would it? In this lecture, we're going to do a quick run-through of all the basic mathematical operations, and also a very useful one called the Modulo function, which might be new to some of you. We're also going to introduce you to another variable type called the float, and go over a special difference between doing maths in Python 2 and doing maths in Python 3, which can trip a few people up. So by the end of this lecture, you will be able to add, subtract, multiply, divide, and use the modulo function on numbers in Python, and that's going to serve as an excellent and strong foundation moving forward. You'll also have a deeper understanding of what operators are, and you'll also be familiar with a new variable type, which is pretty cool, right? So we have a lot to do, so let's boot up idle and get started. Alright then, so how does arithmetic work in Python? Well, all mathematical operations, like adding, subtracting, etc., all need a mathematical operator. A mathematical operator is just a fancy word for a symbol that lets us do a certain mathematical task, like adding or subtracting or dividing or whatever. So let me show you what I mean. Let's say we wanted to add together 2 and 3. Well, we would type 2, just like in here, just type the number 2, then the addition operator. In Python, the addition operator is just a plus symbol, which, makes sense, right? And then the number 3. When we hit enter, Python is going to know, because of the addition operator, to do an addition between 2 and 3. So all we have to do is type 2 plus 3, Python's going to do the rest and give us back 5. The key point that I'm trying to hammer home here, it's the operator that tells Python what it needs to do. So for example, what about subtraction? I bet you can guess what the subtraction operator is, right? That's right, it's just a minus sign. So let's say if we wanted to subtract 20 from 100. The way that we do that is 100, subtraction operator, 20. And when I press enter, Python's going to do 100 minus 20, and it's going to give us 80 back, which is correct. We can also combine together these operations. So for example, if we type 100 plus 20 minus 80, what that's going to do is it's going to give us 40. Okay, so now that we have addition and subtraction down, we come to multiplication, the bad boy. Right, so the multiplication operator is an asterisk or a star. You can find this by pressing Shift and then 8 on your keyboard. It looks basically like this. Okay, so the way that you do this, let's say if we wanted to find what 2 times 2 is. Well, for that we need the multiplication operator. So 2 multiplication operator 2 times 2, Python's going to give us back 4, which is correct. Now, as a matter of style, it's always good to put a space around the operator. So, like, instead of just typing 2 times 2, it's better to do 2 space times space 2. Just like that. And this just makes it look nice, really, and just a bit less cramped. So that's something you might want to bear in mind. Now we come to division. The division operator in Python is the /. Okay, just like when you're going to a website or something. It can be found next to the question mark on your keyboard. But anyway, if we wanted to find what 2 divided by 4 was, we do 2 division operator 4, and it's going to give us 0.5, or 1/2. With another example, we could do 10 divided by 5. It's going to give us 2.0. Interesting, isn't it, the way that we've got this 0.0 instead of just 2. Now, if you're following along on Python 2, or if you've ever used Python 2 before, you'll find this a bit strange, because one thing that Python 2 used to do was every division would just give back a whole number. Okay, so if I did 1 divided by 2, it wouldn't give me 0.5, it would just give me 0. And that used to make all sorts of problems, okay? Used to mess everything up sometimes if you didn't catch it. But in Python 3, that has been, I guess, fixed. The problem's kind of been removed. So the divisions now always give back a decimal number. But how is it actually giving back a decimal number? Because numbers in Python, and I guess in most programming languages, they're not all created the same. Okay, there's 2 different types of data that represent numbers. The first type we're already familiar with is the integer, or int. So let's say let's take the type function of the number 2. It's going to tell us it's an int. If I take the type function of 0.5, we're going to get this other one here called a float, or a floating point number. A floating point number is just a fancy way of saying a decimal number, basically. So we've got this completely different data type called a float that allows us to get extra levels of precision in our numbers, so we can go to decimal places rather than just dealing with whole numbers. This is kind of more or less automatically done, but it's something to bear in mind. Numbers are not all the same. They're basically 2 different data types, one for whole numbers and one for numbers that have a decimal point. The reason there's this difference is because basically, if you want more levels of precision in your numbers, you need to be able to store more information. So floats actually take up a bit more space in your computer program, a bit more memory than integers do. So a float takes up 16 bytes of memory, whereas an integer in Python only takes up 14 bytes, which is actually rather large as far as integers go. I think Java, it's only 4 bytes. So in Python, a float is 14% larger than an integer in Python, but you get all that extra precision. So it's just something to bear in mind. You've got 2 options available to you. Yeah. So with division out of the way, let's move on to the last topic in this lecture with regards to these operations. Quite quick, right? Called the modulo function. Now, the modulo is weird, but it's very useful, and it basically allows us to find the remainder of a division. Okay, so the modulo operator is the percentage symbol. So, and you can find this in case you're looking for it. It's pretty much just you press Shift and then the number 5 on your keyboard. So, for example, if we did this 5 modulo operator 3, we get 2. And why is that? Well, the reason is, it's not because 5 minus 3 is 2. No. The reason is because 3, if you divide 5 by 3, 3 will go into 5 once with remainder 2. So let's try another example. If I did 10 modulo 2, we're going to get 0. Why? Because 2 goes into 10 5 times and there's nothing left over. So the modulo returns 0. Basically, 10 is exactly divisible by 2, so there's no remainder. What if we do 7.5 modulo 5? Well, that's going to give us 2.5. It's going to give us 2.5, and the reason for that is because 5 goes into 7.5 once, and 2.5 is what's left over. So you can see the modulo operation, although it's a bit weird, it gives us the remainder of a division, which is sometimes quite useful. So yeah, I mean, we've really covered quite a lot in this lecture. I mean, as far as content there, we've learned how to add, subtract, multiply, and divide, as well as use the modulo function. And you've also learned about a key difference between numbers in Python. They're not all the same. You've got integers and you've got floats. And you've also learned about a difference between Python 3 and Python 2. Python 2, whenever you used to use division, it always used to make it as integers. There was no concept of floats during division unless you directly expressed that you wanted floats. But in Python 3, you don't have to worry about this anymore, and it won't cause any problems when you're doing it. So divide away, I suppose. So what have we got next? Well, in the next lecture, we're going to learn about how we can combine all these operations together to make rather advanced operations. And we're also going to learn how to make sure Python works out the answer in the way that we want it to, rather than it calculating something behind the scenes. Now, this is a very useful skill, and it will stop things going wrong and you not being able to notice it. So it's very useful to know whenever you work with numbers in Python. And as usual, I can't wait to show it to you. So I'll see you in the next video. The great thing about computers is that they will do whatever we tell them to do, and they'll do it very, very quickly. But at the end of the day, computers are just machines, and they can't really think for themselves. Just yet, anyway. So sometimes we think that we've told the computer to do one thing, but in fact we may have told them to do something totally different, and one particular time when this can happen is when we're doing calculations. So in light of that, in this lecture, we're going to go over some common mistakes when doing maths in Python and on computers in general, and we're also going to go over how to prevent them from happening. And by the end of this lecture, you'll know how to order your mathematical operations in Python to prevent things from going wrong. So let's boot up idle and get started. Okay, so here we are in idle, and let's say we want Python to work out the answer to 2 times 5 minus 1. Okay, so 5 minus 1 is 4. So 2 times 4 should give us 8, right? So when I press enter, oh, we get 9. But why does that happen? Now, the reason we got that issue in the previous example, where Python gave us an unexpected result, is because mathematical operations don't always follow what makes sense in our head, but they actually follow what's called the BODMAS ordering system. Now, the BODMAS ordering system is just 6 letters that represent different mathematical operations, and whatever is at the top, basically close to the letter B, gets ordered first or gets more priority, and what is towards the bottom, by that I mean closer to the letter S, gets lower priority. So what's the letter B? Well, the letter B stands for brackets, or you may have heard of them called as parentheses. So whatever you put inside brackets is going to be executed first, because B is at the start of BODMAS. After that, we have order, which refers to squaring numbers, cubing numbers, or raising any number to the power of something else. Okay, so cube roots, square roots, all that stuff. That goes second. Then we have division, which is, where you divide 2 numbers. Then we have multiplication, where you multiply 2 numbers. And no points for guessing, A stands for addition, and S stands for subtraction. So the main takeaway from this is that brackets can be used to force operations to occur in a specific order. So with that in mind, let's have another look at the example we just did now to see if we can get the answer that we wanted. So here we are back in our shell, and let's have another look at our equation or our calculation to see what might have gone wrong. We wanted this calculation to give us the number 8 because we thought 2 times 5 minus 1 should give us 8, because 5 minus 1 is 4, and 2 times 4 is 8, right? But that didn't happen. It gave us 9. And the reason why is because Python follows the BODMAS system. And in BODMAS, multiplication happens before subtraction. So what actually happened is Python did this multiplication first. It did 2 times 5 and got 10. Then it subtracted 1. 10 minus 1 is 9, which is the answer that we got. So we want to get 8. And the way that to do this, we need to force 5 minus 1 to be calculated first. So to do that, we can do 2 times and open up a bracket and put 5 minus 1 inside the bracket. Okay, so now because brackets are at the start of BODMAS, 5 minus 1 is going to be forced to be calculated first to get 4, then 2 times 4 should give us 8. So there we are, we've got the same numbers on the screen, but just by using BODMAS to our advantage, we've actually got a completely different answer. And this is something to bear in mind because, you know, if we'd just gone ahead and wrote this line of code and didn't think about it again, we might think that it's working correctly, but it's actually not. It gave us a different answer to what we wanted. So by using BODMAS and knowing about it, we can actually control the answers that we get and make sure that the maths that we do in our code is free from errors. The concept that mathematical operations have different orders as dictated by the BODMAS system is a really useful thing to keep in mind whenever you work with numbers in computer programming, because it'll stop your code from doing something unexpected and it'll stop really rather hard to spot errors actually cropping up. So when in doubt, use brackets. I mean, they're free after all. In the next lecture, we're going to build our first mini project, and in this project, we're going to imagine a player that has just walked over a special health potion in our game that gives them a random amount of health. We're going to make a random number generator that can be used to randomly generate some health for your player, and then update their health depending on the difficulty system. So it's going to be super awesome. So I'm not going to waste any time here, and I'll see you in the next video.